Welcome to Ask and Learn.
Let's use the ratio test to determine whether the series converges. So here, let's look at this term, an. An equals n factorial over n to the n power. Now the ratio test suggests that we look at this limit here, absolute value, an plus 1 over an. So let's do the numerator in red. So that will be n plus 1 factorial over n plus 1, n plus 1. Then that's being divided by an. An is n factorial over n to the n. Let's write the absolute value. You could ignore the absolute value because all the fractions here consist of positive numbers. So now let's go ahead and simplify this. So let me rewrite this n plus 1 factorial as n factorial times n plus 1. And then I'll also have this n to the n power. Then I'll have this term here. So let me write this as n plus 1 to the n times n plus 1. And we still have one term here, n factorial. Now let's go ahead and cancel out as much as we can. We see those factorials go away. N plus 1 terms cancel. So we have the limit n goes to infinity, n to the n over n plus 1 to the n. Now I'm running out of room here. Let me take this to the next page. Now let's rewrite this as n over n plus 1 to the n. Now this looks familiar. If you consider this fraction over here, the reciprocal, split up that fraction. And let's even put it to the n power. If you recall this expression here, if you take the limit, this is equal to the number e. So this is the reciprocal of our term. So that just means that our limit just goes to 1 over e. Now this number is less than 1. So we can conclude that the original series, the sum from 1 to infinity, n factorial over n to the n, converges. By the ratio test. And that's our final answer.